So it's kind of connects with the other packages also, and it plays very well with the scikit-learn, which is the other machine learning package. So you can use it, all these data frames in the scikit-learn machine learning stuff also. So let's start with the. This is just a introduction. I have just added some CSS style to make the fancy data frames, but it's not necessary. And so I'm just basically ignoring the warnings in the previous line. Here I'm trying to find out the package or version of the Pandas, and I have also imported the matplotlib in case I want to have some charts. I also have, if you see, %matplotlib inline, which allows you to have the charts inside the Jupyter notebook instead of popping out of the notebook, which is sometimes very annoying. So these are the initial preparation. But basically, I will be using the open policing Stanford data, which is basically how many times that the people have been stopped and been fritzed, and is there any violation, and when it was used in one of the Pythons. So there are two parts to the whole talk that I'm gonna have. One is the tutorials of covering key facets of key aspects of what are the various methods we have, and then we'll try to answer some of the questions based on that. So let's start that. So I have this police.csv file. So it's loaded. Before I look into the data, I want to look what kind of I have loaded into the DF variable. I want to see the type of the DF. So it's a data frame. So that's type can be used to find out the type of the various data objects like data frame, series, and various other things. Now, as Jack mentioned, head can be used to look at the first 5 rows, and here we go. So we have like the stop time, stop date, stop time. This data is only restricted to the Rhode Island data. So we have the driver genders and driver age. Some of the variables were different for a different state, so they have been standardized. So there's a violation row, violation, search conducted, and so forth. And we'll go through some of the variables as the cases come across. Now, the first thing I want to see is that, hey, what's the size of the data set? How many rows are there? How many columns are there? So whenever the data frame is created, we have a shape attribute that gets associated with this. So if you run it, you get the tuple, which shows the first element of it tells the number of rows. The second element tells you the number of columns in that. You can pull out 1 or 2 based on that. Alternatively, you can use the len function, which is like typical vanilla Python function. So it will tell you the number of rows. Now, if you want to look at the type of the columns, then you can use the dtypes attribute, which is and as you can see, I'm using the dot notation here. I'm chaining the various attributes through the data frame variable. So that's very convenient. So we have all these variables. Some of them are float, some of them are objects. Objects are mostly strings.
Do you know why your year is coming in as a float?
Here.
I'm pretty sure it's the default. Like unless you specify,
yes,
it wants everything as a float.
You have to pass it through pd.datetime function, and if it's in the right format, then it will convert it into a year, or it can convert, if it's a timestamp, then it can do other things also. So I have one case, like an example here, so we'll go through that.
So the search part was that another number.
Yes.
That was the only one that said that. The other ones are objects, but it didn't say.
I was kind of curious.
I've actually no experience with this specifically. So when you import it, or when you create a data frame, if the data is null completely for a column, it will allow that to be a string. But if it were, it'll just actually call it an object. It'll be like object. But if you have things that look like integers, but then you have null values, it goes, well, NumPy doesn't support null integers, so that's a
Yes. Yeah, but they should be soon. Yeah, should be soon. If not,
Integer is an object.
Right.
But it hinges on NumPy's array.
right. Yeah, it's because NumPy doesn't support it, but it yeah, suppose it will.
That's
Yeah.
why you get the NAN.
Yeah, that's what you did.
And just FYI, this is from learning the hard way. I learned Pandas first before I really got serious about NumPy. If you learn NumPy first, Pandas is a breeze to understand. So don't be like me.
Okay.
Quick question. One more. What do you use info? Do you use dataframe.info?
I didn't use that, but yeah, it's another. We can do that. Yeah. Sorry for. So that's another way. So that's another very good method which tells you the non-null objects. And for example, stock date has all the non-null objects 914, 741, and there are many of these.
I'm gonna describe.
Yeah, describe is another function for that. So there's so many. One of the things with the pandas is that you have the multiple ways to do the same stuff.
Do dir on DF. just so you're aware of how many methods there are.
Yeah.
This is good. I'm curious. I've never counted.
Yeah.
So it will tell you all the. Sorry, it became.
It's too many.
So it shows all the possible variables that's associated with the data frame.
That's true for anything Python. dir and then we'll take all that.
Right.
Free.
Yeah. So D types, info, describe, all covering almost similar kind of stuff. So yeah, but these are really good options to explore the data set. So whenever you have a data set, you want to explore all these things initially before rather than doing it later. So it's really a good practice to kind of use these variables. Another attribute which I want to highlight is the columns. So if you do the read columns, then it will tell you the list of all the possible columns in a list, which is pretty straightforward. So this covers really high part of looking into the data set in first few seconds, and then now we want to do some kind of operations on it. So one of the things is you want to get this. If you want to get the series, there are multiple ways to get the series. You can use the bracket notation. You can use the dot notation. So for example, one of the variable in the data frame is driver age. So if I want to just pull that, it will give me the indexes and the driver age variable. Now, I just want to highlight this thing that with the data frames, always there is going to be indexes. So, and we will cover some part of it in the later part, but indexes is a good way to filter the data sets, and you can also replace the default index of integers, natural numbers, by some of the column also. So that becomes a good filtration criteria. So that's the way you can you can use dot notation also here. So this will give the same stuff. Dot notation is easier rather than bracket notation, so most of the time I use it. But if the variable has spaces, some kind of alphanumeric character or the special keywords, then it wouldn't work. But yeah, it comes pretty handy. So yeah, now the way the Python works, similarly Pandas has this chaining of operations. So for example, here I have picked the series, use the data frame df, and using the dot notation I pulled a variable or the column name which converts it into a series, and then I'm pulling the first 5 rows. So let's see that, and yeah, it works. If I want to see the type of the series, then it's the series. So anytime you want to see the type, because there are other kind of objects also in the that I'll show you later on, which are not just series and data frames. There are group by data frame objects, which also comes very handy. So let's do some kind of operation. So one thing that is very handy in Pandas is that whenever you do any kind of mathematical operations or any kind of operation or string concatenations, it happens at the element level. So if there are 10 rows, it will happen for all the 10 rows. For example, I have created a data frame H based on the df.head, so it will gonna give me 5 rows, and I'm just pulling out one variable or column into a series. So it's gonna be 20, 40, 33, 99, whatever the values are. If I multiply it with by 1,000, then it will multiply that 1,000 with all the possible values. You can do all this thing through the for loop also, but that's the easiest way. So there are multiple ways, but this is the Pandas easier version of doing it.
It's actually a lot faster.
Yeah, and it's memory efficient. The another thing I wanted to showcase here is you can also concatenate strings, or you can create new variables. For example,
We're on that Operation 107 didn't change the values, it just displayed them with that.
exactly. If I want to create H,
Gotcha, okay, I understand that.
yeah, and then it would create in the data frame a new series which would be multiplied by 1,000.
Thank you.
So that's what I'm actually doing in the next step, where I'm creating. I have two columns, the two series, violation and the stop outcome, and I want to create a series which is the concatenation of both. So there are multiple ways to do it. The easier way is just like we do it in the Python. You just add it. I have added it, and I want to show it. So now we have this variable speeding citation, and previously we have like other as drivers. So all these are connected. So you can do all these kind of operations at the element level just by a single row of command. The next thing that I want to cover is filtering. Filtering is one of the things where you want to filter the data set based on certain conditions, and I want to go into detail into that to explain how it happens. So let's first look at the same data set of 5 rows that we have. It's the first 5 rows. There's nothing fancy about it. If I write the condition like this, where I write a series and I do a comparison operator where I'm saying that, hey, is the driver age greater than 20, then Pandas understands that you want to do a comparison, and then it will return a series of booleans, true or false. So it will have the indexes and the true and false. So what you can do is, the good thing about it is, if you want to filter your data set based on that, you can, I created a variable based on that. You can create a variable also, but you can pass this this condition inside the data set of H. So then it will pull only reports which are satisfying the condition or are true in that Boolean series. So we have like 3, 0, 1, and 4 which are true. So if I run that, so 1, 2, and 4, only those variables comes out. So basically, you can do a lot of things. In the bracket notation, you can use the series. You can pass the filtering conditions to filter the data sets. You can pass on the multiple filtering conditions also, and it will work the same way. For example, I want to see the driver age between the greater than 20 and less than 40. So it will also once again return me a Boolean series, but the ones for the only time you have to put the parenthesis is in this situation where, because you have two conditions and you want to order them and you want to kind of separate them, and then you will use the bitwise operator which I have used, and character here, ampersand character, so which would work here. So it will give me the true false, and I can once again pass it inside the data frame in the square, the bracket notation. So it will give me the results as we had with a single filtration condition. If after that data set, I want to look at the only one of the column or one of the series, like violation, I can add that with the chaining function with the dot notation, and it will give me only those two values. So yeah, so you can filter it through using the bracket notation, and you can use the the ampersand sign for the and if you want the or condition, use the pipe character. So that's few things about the filtering. We can go far more, but probably that gives a good idea about how to filter the rows out of the data set. Another thing I want to showcase here is if we want to make, instead of the natural numbers as the index, one of the column as the index, then we can use the set index method. So one of the column is stop date, and I want to set this as the index. So if I run that, here it didn't find.
Because I think you already ran it.
Yeah. So if I run the
You can't run it.
yeah. So let's see df. So see now the index has been changed to the stop date. You can make multiple indexes also. So multi-indexes where you can have stop date, stop time as the indexes, or you can use it in the columns also. So let's reset it back, and when you use the in place equal to true, it actually works. If you don't use the in place equal to true option, then it will just temporarily do it, and after that it will not remove it essentially. So it will be just a temporary thing. So now if we look, once again it's back into the original format. So let's yeah.
Even index, is it more like a binary key of a table just using an analogy here, or is it something different? What does that mean? I understand like we use index and indexes now, like almost all the operations is done. But in terms of trying to conceptually visualize what role it plays,
Yeah, so index has multiple roles. One of the role is that even if you filter the reports, the indexes of that rows will be unique. So
Is it doing some kind of an hashing using the index to hash table kind of a thing? Or?
In terms of index, I was just explaining in terms of the group by function.
Okay.
Yeah.
But it does do something like that.
Got it.
It does give you a, I guess it behaves more in a constant time versus, like, so when you index it, that's what I was saying about grouping it together, it won't have to look at a million lines to go through and pull, and say you want to filter. If you put it in the index, it'll just go and get that set, and it wouldn't have to look through the entire list of everything to see if it matches this. So you get that as well.
Are you a database guy?
Little bit, yeah.
Non-clustered indexes, closest thing. So, doesn't require uniqueness, but allows you to access stuff very quickly on that side.
And you don't see that performance until you get into the tens of thousands of records, especially if you do D-type STR. If you make everything a string and you get into the tens of thousands, that's where using indexes a little bit more intelligently starts to benefit you. But if it's a small data set, it really doesn't matter.
And for argument's sake, like we could still do the group by even though whatever column or whatever is an index, right? The exact
Yeah, but you need to group by with a specific column in mind, right? Like what you want to group by. It's like a standard querying where you group by, and you also need to provide like what columns that you need to take a block of.
Agree.
So it's basically converting the same SQL to a Pandas Python code.
That's a whole presentation in itself, as you can see, the index.
For example, one thing I also wanted to highlight that index need not to be just numerical. For example, if you do the df.describe function, the index becomes these values: count, mean, standard, 25%, and you can filter on that, which we'll look soon in the log function. So what is log function essentially does? Log function basically pulls the data or one variable or multiple variable based on the indexes. So the way it's written down is that you use .log. You pass on the multiple ways you can pass on. Right now I'm passing 0, which is corresponding to the 0 index, the first row, and I want to pull out all the variables out of it. So this will give me the first row of the data set. If I want to, yeah, so it's now
Yeah.
have converted into a series. If you want to pull out multiple rows, then you can pass on a list inside the square brackets of log function, and this colon says that you want all the variables. You can, instead of that, you can also do just 0, 2, just like a instead of passing the whole list. So if you run this, it will give 0, 1, 2. I just want to highlight that in the log function, the last element which you have given is inclusive, which is not the way typically things work in Python. So just be aware of that. If you want all the rows and one variable, which is basically like a series, then you can do that.
So this log function work on indexing.
Yes, it works on that.
If you change the index to something else,
Then you can pass on that value also.
so the number get rearranged according to the whatever value we pick, right?
Yes. So for example, if you have used the stop date, then you can pass on that given stop date as the first value, comma, whatever the variable you want to pull out.
If you sort based on that index, then the order.
Yes, order will change, yes. So you can use the sort values or you can use the sort index functions. So sort index function will work in this case.
You can always go back to where you were as long as you don't actually change the data frame, right?
Yes, so indexing can change the ordering, but the data content will not change.
Gotcha.
It's just like a database where you have all the possible rows. Let's look at this one, another version of it.
What is the significance of the log function? You can do this even without the log function, right? Just by slicing the data frame.
So this is, for example, as you said, that it could be done through the slicing or through the filtration. It can be done, but this is more Pythonic way of doing the pulling the data, and so it's being more accepted. So that's why I think I tend to go there rather than using just filtering all the times. So yeah. Going forward, so one of the things which I was also wanted to highlight is in the log function, instead of just passing the index, you can pass the conditions also, which will be evaluated, and based on that, those indexes will be taken out. For example, I use the df.log and df.violation equal to speeding, so all the rows that evaluates to true will be pulled out with all the variables because I've used the colon here. So this is something I was also referring to. This is another Pythonic way where you can just say df and just pass the condition and you will have all the possible rows. So, yeah. Let's move to the group by function. And the way I would define a group by function method, yeah.
Just go back up to that, just a little bit there. Just wanted to see the method again that you
Sure.
applied there. So you can put your logic inside of the invocation.
Exactly. So you can pass the index numbers list, or you can pass the conditions, and that will evaluate whatever evaluates to true will be spitted out.
Thank you.
So group by objects is the group by method or function. Basically, what it does is it creates a different kind of object in itself, and first of all, which I want to showcase you, and then based on each element, it will kind of groups at different for the different aggregate functions. For example, let's just look at the data set once again. We have all this thing, and I want to group by the driver age, which I have been using like all the time. So, so let's run this, and we see that when you use the data frame C, which I have created just with the same data frame DF, and when I use group by on the driver age and try to find out the type of that of object, that's data frames group by, and it's kind of a compressed data in it, and you can use it in multiple ways, and I'll show you that. For example, on this group by object that you have just created using the group by function, if you find out if you connect it with another series is arrested and then add the sum, then it will do the summing at the driver level. And let me show you the output. So things becomes more clear sometimes when we have the output. So it basically grouped the counts or the number of observations where the driver age when the person was arrested. So if it was true, then it became it summed up as 1, and false, it just consider false as 0. So for example, we have this thing.
Got too many 9-year-old people got arrested.
One of the interesting thing is, which I also want to highlight, is sometimes you see zeros here, but in the last 4 observations, we have false. Because what happened is, if we have true, sorry, 1, then it will say true. So what it does is, if there is false, then it takes it as 0. If it is true, it takes it as 1. So if there are multiple falses, it tried to add it up, so it all became 0, 0. But there was a single observation for 89 age group where there was only 1 false, so it didn't converted it into 0. So sometimes you have this difference in the data type, so you need to be aware of that when the data is like that. For example, if I look, let's look at 89 and 88. So 89, there was 1 observation, and is arrested variable is false. So it was not able to sum it up. But if you look at 8, there were multiple observations, but all were false. Is arrested false. If you look at, on the other hand, for the 15 age, it's summed up, and it has multiple observations, but true are 3. So that's why we see for 15-year age group, the number of is arrested people as 3. So one of the interesting function, you can group by definitely based on multiple series. I'm doing it by the driver gender, and it gives me gives me for female. So you see here the driver gender and the driver age have become the indexes here, and all these sum, size, min, max, mean have become the columns, and you can see all these aggregated values. It's pretty much like you can do the describe, but describe is only for the numerical values, for numerical series. But using the group by, you can do a lot more with the categorical variables. Okay, so that's one thing. One thing which I wanted to kind of use this as finding out is if you want to find out how many null values you have in each column, then you can use the isNull dot sum function, and what it does is it tells you that how many non-null, all the null values are there. Sorry, not null, the null values. So how it works is, I want to go into its detail a little bit, that if you use the df is null, then it will convert every value into true or false based on whether it's a null or an AND. And then you use the sum operation here, which converts it into a series of all these series variables and sums it up based on the true values. So that's also one of the good exploratory way to find out how many null values you have, and if you want to replace it with something. So yeah, pretty much this was talking about the various few things that we can do from the pandas. I have also some exercises. If people feel a little tired, but if everybody is interested, I can go through those quickly. So one of the thing is remove the columns that contains the missing values, and there's a typo, it contains all the missing values. So from the here, I found out that county name has all the missing values. So the way you can drop a column is you can use the drop function, and you can use the county name as pass the name of the series. And the important aspect here is the access. So if you want to delete any columns, then you can pass on the columns. If you want to delete instead of that some rows, then you can write the rows here. Previously it was 1 and 0. Now it has been the pandas have kind of made it more explicit as columns, and in place equal to true.
And does that actually change the data frame?
Yes.
Because you do in places true, right?
Yeah, right. So if I run this, now there is no county name here.
You can't do that without reloading it.
That's correct.
Okay.
Another thing which I want to talk about is if you want to find out who was speeding more often, was it men or women?
This is actually just who got caught.
Maybe they're smarter than you.
You can only analyze the data you have.
Which ones resulted in cycles?
So what I've done is, for finding out, I use the violation series or the variable and put equivalent to speeding and filter the data set, and then for that data set I pulled out the driver gender variable and I've used the value counts function. So here I want to introduce the value counts function. It's basically based on each category, sums up how many times that value has occurred. So, and I have also used the normalize function, which I can ignore, but if I normalize function basically converts it into %. So if I just
Parentheses.
Oh, right. So you can similarly look at the kind of violations that the males have done. It seems the highest number of violation is by the males is speeding, and for female this seems to be speeding too, but it seems female are doing more speeding. You can use the you can group it also by the doing it instead of separately. You can use the group by function here and use get the same results. So now you have grouped it by the driver gender and use the violation variable, and for that you get a different percent. There is another way to do it. You can use the log function here, but I'll just not go through it. Let's look to another task. Does the gender affect who gets searched during a stop? So we have a search conducted variable, and we will look through this. First of all, we'll just look true and false, how many times somebody has been searched, and then we can group it by the driver gender and find out the mean values. So it seems males are more searched. The one thing about the value counts which I want to kind of highlight is that it ignores the NaN values when it counts the things. So, and it actually happens with a lot of aggregate functions in Pandas, so you have to be very aware of either using the drop n equal to false option, or you just make sure that the nans are getting, you're aware of it. So let's move to some of the string methods which we were talking about initially during the Jack's presentation. In normal Python, if we have something like a variable which is a string, you can use just dot notation and then use the upper function, for example, if you want to make it uppercase. Here in Pandas, you have a lot of string functions, but you have to use the .str before using it. So I have just opened the API reference here, and so I think let's go through this. So we have capitalize, cat, center, contains, a lot of string handling functions. If I search through string handling, it would be this one. But the only difference is that before using that you have to put .str dot. So going back to the one thing which I wanted to find out was in this task that how often is the driver frisked, and we have a search type column which has different strings, and I wanted to find out whether it contains the frisk. So I used the protective frisk as .str contains protective frisk as the string, and created a variable out of that. And based on that, I can find out how many times somebody has been frisked. So if I run it, I get NaN, false, and true. And we can
So did that actually create a new
Variable,
column
yes.
in DF?
Yes,
In the
that-
data frame, right? Okay.
That's correct.
Gotcha, and then you summed it, gotcha, okay.
Frisk. Yeah.
Gotcha, thank you.
Similarly, one of the questions that you can try to find out is that which year had the least number of stops. So, if you look at the data, the way data has been presented to us is that we have stop date and stop time. So you can And somebody pointed out it's an object format, it's not in the date format. So we have to convert it into a date format. So what I did is I concatenated the stop date using the cat function, the stop time, and kept a separator as space. And when I looked at this series, it looks like this, but still the D type is object. So the way to convert it into a data time is, a date time stamp is, use the toDateTime function. So this, I pass this series to the datetime function, and when I look through this, it's running.
PD is your alias to Pandas.
Yes.
Yeah, almost everyone abbreviates it that way. Just it's taken over. And NumPy is in.
Yeah, that's why Pandas is PD, is because NumPy, the convention took hold to.
Now if you look at the stop data time, it's into date time